I'm just going to hit record to get us started. But as I said, welcome everyone to the webinar today. My name's Rachel Lammy. I'm Director of Product at Crossref, but I'm also the co-chair of the Scholix working group, along with Helena Kuzan from DataCite, with Lorenzo Fieri from Elsevier, and Paolo Manghi from OpenAir. So welcome to the session today. Happy to take questions, have some discussion. And Helena, I think I can probably pass over to you to kick us off with some slides.
Yeah, definitely. Thanks,
Thank
Rachel.
you.
Let me share my screen. There we go. So yeah, hi, I'm Helena. As Rachel said, I work for DataCite and I'm one of the other co-chairs of the Scholix working group. So really great to have an opportunity today to talk a bit about the work that we're doing within the group, within this webinar on expanding Scholix to support software. So I think probably many of you will be familiar with what Scholix is, but I thought it would still be good to start with that so that we're on the same page about what we're talking about. So Scholix stands for Scholarly Link Exchange. And what's very important to know is that Scholix is a framework. I think sometimes there is a bit of confusion about that in the community. So let me emphasize that from the start. It's a framework that was developed by the RDA WDS Scholix working group, which I think started already in 2016. So we've been working on this thing for a while, and there was actually already another working group under another name that did some of the preparatory work for this group. And so Scholix, the working group, developed a framework for standardizing the exchange of scholarly link information between scholarly infrastructure providers. And so the group realized that there's a lot of value in linking research data with the literature. And I think that's still true today, still something many of you I'm sure are thinking about, making research data available, citing data in articles, and establishing those links between articles and data sets. So yeah, back then in 2016, we thought this is important, but right now there are many disconnected sources and a heterogeneity of practices, different types of PID systems, different ways of referencing data, of citing data, of establishing connections. And I think to visualize that a little bit, at the time, there were relationships between publishers and data centers and repositories that were exchanging information about the relationship between data and articles. So that was happening, but it was often sort of just happening between two within bilateral agreements. So one publisher getting information from one repository, and it wasn't really done at larger scale and not always available to the wider community. And so therefore, the working group worked on a framework to develop a standard set of guidelines for exposing and consuming links. And for that, we implemented a kind of hub model so that publishers and data centers and repositories could send the information they had about the links between articles and data sets to specific hubs that they were already working with in many cases. So for example, publishers, many of them register DOIs with Crossref and they deposit metadata with Crossref. So then within that metadata, they can include information about the links between an article and a data set. So for example, when a data set is cited in an article. And then for data centers and repositories that are registering DOIs with DataCite, they can also include this information in the metadata. So when they know that a specific data set underlies an article, they can include that in the metadata. And also organizations with OpenAir can directly contribute this information to OpenAir. And then we all make that available in the same way so that all that information is aggregated and available to the community. And so for that framework, what we did is establish the Scholix schema that was already released in 2016, but has been updated over time. And so within the schema that you can find on Zenodo, we have fields to describe the source object and the target object, and then importantly also the relationship between these objects. So for example, a data set can be referenced by an article or be supplement to an article, and an article may say it references a data set, but also the other way around. And so this is based on the existing metadata schemata. And so that way we can exchange information about these relationships in a standardized way that makes it easier to aggregate the information. So for the last, I guess, 7 years, the focus has really been on linking articles and data sets, and we think the schema works well and it is actively used. So information is contributed using the schema. And of course, adoption could still be better, and that is something we're also still working on. But yeah, now that this is actually working quite well for articles and data sets, the group started discussing, what about other research outputs? Should we maybe be expanding this to other research outputs? And then a very good candidate was software. And so for the last year, that's something we've been looking at. And I think at this point, I'll hand over to Rachel, who will tell you a little bit more about our considerations.
Cool. Thank you. Let me bring up my screen sharing. Okay, so you should be hopefully able to see that okay?
Yes.
Excellent, thank you. So you said the working group has a, it has a real mix of members, and I guess even though the group's been in maintenance mode, we've still been meeting regularly and running sessions at the various RDA plenaries, both in person and remote, over the past couple of years. And we got on to talking about research software, obviously, because it's something that's an area of focus for some members of DataCite, and it's something that's, I guess, increasingly an area of focus and interest for RDA members. So we've been thinking about, we've been talking about data, we've been talking about sort of, making sure that data is represented as a first-class citizen, as a research output. And, by the same token, you can extend that to software. It's the result of scientific thinking and skills to create software. And as such, it should be recognized and rewarded. Because, a lot of the goals, I think, of a lot of our organizations are to foster openness and the sharing of all scientific outcomes. And also a key piece is also to support reproducibility. I don't need to tell you that that there's a lot of focus around research integrity and ethics at the moment, and I think that the transparency of the availability of the research and the transparency of the pieces that all of the different pieces that support research, I think can help support science. And the transparency of that. There's also infrastructure for research software, which supports a full software publishing life cycle. Publishing, yep, there are DOIs for software. I know that's something that DataCite are seeing more frequently. Obviously, there are other identifiers, and I would extend that to data as well. Being able to preserve software, so initiatives like software heritage, and then being able to create those links and relationships between software, data, and other research outputs are really key to achieving the aims above. I think from our perspective, what we really didn't want to do was to try to enforce I guess, kind of standards or a framework on software. But I think that some of the information that we were starting to look at and see in our systems, we could see that folks were already using the kind of relationship model that that Scholix already supports, and the organizations like Crossref, DataCite, OpenAir already support to be able to establish those links. So we'd always said in Crossref, you know, we can support links between different research objects using the relationship section of our schema. And whenever we had a look in our event data service towards the end of November, we could see that there were growing amounts of events between articles and software and different repositories, even back, I guess, sort of 18 months ago, and these have been growing since then. So we could see that these links were already being established and making their way through our systems. From the OpenAir perspective, this is some data that Paolo sent through. So again, you can see lots of dataset to dataset links, but also links between software and datasets, publications and software. And these are the kind of, I guess, kind of bringing in a sort of a more sort of standard mechanism to be able to support these will make them easier to use and track, and to be able to again reward and recognize researchers for sharing more of their scientific process. And from the DataCite perspective, again, there are certainly thousands of events already existing between software and data, and around 13,000 events between software and articles. So, and again, this is reliant on the relationships or that section of the schema that that DataCite support as well. And this is a mechanism that we're using to exchange information with DataCite at Crossref, so that we can so that these links and this network of information doesn't get siloed within one registry. And I'm sure you can think of more as well. So I think the point is, with the community that we're part of, we're seeing these sort of links start to percolate through already, and we're keen to be able to support those in a sensible way. And I guess just an example in the wild, looking at this example from PLOS One, I can already see in the reference list, I can see a link to Zenodo, pointing out to an R package that's being referenced as part of this work. So I guess there's sort of two things. There's the just citations to software and reference lists, but there's also data and software availability statements. So you can kind of make the distinction there between I guess data that underlies the work versus data that's being referenced. But just being able to make the links and use persistent identifiers to make those links already gets us a long way further. Helena's already given this a bit of context, but we could see this kind of movement and increasing levels of discussion within the community around this. Specifically, I know that there's been a lot of work on this via the FORCE11 working group, the software source code working group as part of RDA. So again, we're trying not to, we're trying to make sure that we consult with other folks in the community and recognize work that's already being done, rather than trying to reinvent the wheel. So again, I think that being able to reference a lot of the really good work that's already been done here and using that to inform our approach is has been really helpful. We talked about some additions to the Scholix schema, and this is sort of, I guess, what we wanted to ask about today. As a first step, we've added the object type name software to the schema because that didn't exist previously. So we did, Paolo and his colleagues at OpenAir did that earlier this year, just because we could see that people were already using that. The other feedback that we'd had from speaking to people is that versioning is important for software, so we can add support for version information into the schema. And we'd also looked at, I've talked about those kind of relationship types and looking at the ones that are most commonly used for software already in both of our schema. So in DataCite is supplement to, is version of. And as said, from our perspective at Crossref, we'd advise that people provide links to software where they're citing it in reference lists, just as you would for any other citation, or it can be added using relationship metadata, so is supplemented by or references. So these are things that we support already, but we could, if we can support these in Scholix, then I think one thing we were talking about that we'd like to do is to clarify our own recommendations so that people can use these relationship types consistently. Again, just using the identifiers gets us a long way there, but I know that people like to have and use these recommendations. So this is a chance, I think, to be able to be sort of help the community be consistent in the relationship types that we use. This is sort of what we'd like to discuss today. We're writing that up so that we can publish a new version of the schema on Zenodo, and obviously again invite more feedback using that mechanism. And when we're happy with that, then we'll contact RDA about the endorsement, about the updated schema. So again, folks always ask kind of about next steps. So that's kind of the direction of travel once we've, I guess, kind of, once we've talked about these changes and are ready to publish them. From a software perspective, Neil, can I hand over to you? Neil joins us in the Software Sustainability Institute, is also a valiant co-chair of several Scholix working groups, and is a great person to give you more context in the work that's being done around software citation, and visibility and reproducibility. So Neil, I will let you share your slides. Thank you so much for joining the call today.
Thank you, Helena and Rachel, for giving the introduction as well. And hopefully you can see my slides on screen. So yeah, I was asked to give a little bit of background both on the sort of ubiquity of software and research software, and also talk a little bit about the work of some of the groups that I've been involved with, primarily the software citation working group that's part of FORCE11, but also a bit of context for what else has been going on that will help us understand what software is out there and perhaps how it's linked to other types of research objects. So I think the first thing is to give you an idea of the sort of scale of what we're talking about. It turns out to be really difficult to work out how much software is out there and used in research. I'm going to talk about a little bit of research that's been done more recently later. But two things that we've done at the Software Sustainability Institute to look at how much software is out there from a slightly more orthogonal perspective is firstly to find out how much researchers rely on software. So we've done a survey in 2014, and we've repeated that in 2022 to look at the way in which UK researchers do their research and how much is done with specialist software. So that's software that is being used specifically for research and has some sort of functionality that is around either generation of results or management of them, or processing, analysis, or visualization of the research. And what we found is that almost all of them could not do their research without specialist software. So we've got this big bar here that says it's essential, which means that their research couldn't happen without the software. The big thing that's changed since 2014, though, is the number of researchers who are doing some form of code development. A lot of that is just making small scripts, but some of them are contributing to larger packages or platforms as well. And that's gone up from about 56% in 2014 to around 80% in 2022. So what we're seeing is many more researchers are developing code. The other thing that we've looked at in our attempts to find how much software is out there is to look at preprints and try and understand what proportion of preprints feature something that indicates that software has been used as part of that research. And so the graph on the right is a scan of the percentage of preprints in a study of 31 UK institutions. And it sort of shows the prevalence of software increasing. So in 2000, it was about 6% of preprints that had been deposited that contained something to do with software. And in 2017, it's gone all the way up to 65%. And I think what that shows, because it's preprints rather than published articles, is how much software has just become a part of the research process. So if all of the software is out there, why don't we see more of it around? The biggest problem is that the way that we reference software in the traditional scholarly literature, articles, papers, and so on, isn't very uniform. So this is a table from a study by James Harrison and Julia Bullard, which was looking at the different ways in which software is referenced in a set of different papers. And what they found was that software is referenced in many different ways. So sometimes it's a citation to a publication, but more often it is referred to more like an instrument, where it's just sort of named with a publisher, or in many cases, it's just the name of the software itself in the text. So it's very hard to properly identify the software, particularly as a lot of software has similar names, and a lot of software has names. I'm thinking of things like Java and Python, where it's using a word that is very commonly used in certain other disciplinary areas. So good luck finding Python software if you happen to work with reptiles. So one of the things that we're trying to do to address this is give a set of recommendations for researchers around how to make their software citable and how to cite software. So in 2016, Arthur Smith, Dan Katz, and Karen Nijmeijer led the FORCE11 Software Citation Working Group, which developed a set of 6 principles based on the data citation principles around how you should cite software. And so these are all around why software citation is important, ranging from making sure that we can do proper credit and attribution, to ensuring that we have persistence of the identifiers and metadata, and making the software accessible. So what we did following that is try and understand what would be required to ensure adoption of this set of principles. And when the Software Citation Implementation Working Group was set up, we thought it would be the relatively small amount of work to take the principles and ensure that people were able to use them and put them into practice. Of course, as everyone who's on this call probably is very much aware, it's the hard stage, the adoption and implementation stage. It's very easy to write a set of recommendations. It's much harder to help people implement them. And so over the last 5 years, what we've been doing is ticking off all of the different things, the guidance and guidelines for helping people implement the principles. And so these include looking at checklists for authors and developers, coming up with changes to metadata to make it easier for people to describe citations, looking at the way in which journals handle the software citation data and metadata, and providing best practices for different types of stakeholders, including research software registries, repositories, and so on. What we're trying to do here is basically give that meta guidance to groups and communities so that they can then tailor that guidance for their own purposes. So for journals, as was mentioned earlier, we looked at understanding what are the minimum requirements to apply software citation in guidance from different publishers, journals, and conferences. And so there's a FORCE11 article, F1000 article called Recognizing the Value of Software, a Software Citation Guide, that sets out our expectations of how the software citation principles can be applied, along with some guidance. And so what we do here is we define what the recommended fields for software citation are, including making sure that the authors, the title, and an identifier are placed as part of the reference. And also what are the sort of optional items. So things like versions, and also a recommendation that what should be done is that if an article exists that describes the software, it should be an additional reference as well as the software. So we're trying to discourage the practice, which is to just cite the paper that describes the software and not cite the software itself directly. Because I think if we don't cite the software directly, a lot of that linkage that Scholix enables just disappears. And if you're interested in that paper, we provide some examples of different types of reference and why and how they might be used, and give some examples of what we think is better referencing for software in papers and publications. So what's the problem then? So if we've got the software citation principles, it should really be very easy for us to see all of the software that's out there and link it to the other research outputs. However, what we see is that whilst it is definitely increasing, so this is a study that was done in 2019 looking at the data citation index, and what you can see is that whilst the amount of software citations that are in the wild has gone up considerably, it's probably not as high as you might expect. So if you remember back to the first graph that I showed, we were looking at probably a few hundred thousand records that we might expect to see, and here we're seeing about 67,000 records. And so where's the stuff that's missing? It's just not being cited yet. There was a study done by the Chan Zuckerberg Initiative looking at software mentions in the biomedical literature. So here we see a lot more software mentions. So there's about, I think, about 1 million software mentions in about 2.5 million papers. So 1 in 2 of papers in the biomedical literature have software mentions. But again, there aren't very many direct citations here. A lot of them are just mentions rather than citations with proper identifiers and metadata. So what is happening to change this? So there are initiatives that are helping us to try and get to better metadata and better citation practice. One of them is the support that's been rolled out in Github, which is the most popular code repository for researchers, where they added support for software citation using a format called citation file format in 2021. And we've been seeing a steady increase in the number of projects in GitHub that have been adding a citation file. It has to be noted, though, that some of them are adding citation file formats that point to their software paper, which is interesting. But at least now people are falling into a practice of making it easy to understand how to cite a piece of software in GitHub. And also, and I know Melissa is on the call as well, there has been work in the JATS for our group to develop a recommendation to help enable support for the different ways in which software citations flow through the journal process as well. And I think that's really important, because one of the reasons why perhaps we don't see as many software citations in the wild is simply because it's very easy for those citations to get malformed all along the process, from the original generation of a citation through to the publication of something that cites that software. And finally, the last thing I'm going to mention, which is around helping to improve practice in this area, is the FAIR Principles for Research Software, which a number of the people on the call have been involved in the development of. So the FAIR Principles for Research Software are about making software findable, accessible, interoperable, and reusable. And I think the key thing to understand is that the FAIR for Research Software Principles and the Software Citation Principles are really compatible. They're really trying to do the same thing in slightly orthogonal ways. So you can see all of the principles here that I've highlighted in red are things that meet the criteria of the 7 principles from the Software Citation Principles. So the real key here is things like R3, software meets domain relevant community standards. It's about understanding how to implement software citation, the FAIR Principles for Research Software, in a way that is easy to use in a particular community. So just to kind of wrap up, I think the main thing that I find really fascinating is how much software is out there that we just don't know about, because it's hidden, it doesn't have an identifier, or it's not well linked to other research objects. So when we look at this huge graph of all of the different outputs and some of the figures that were shown earlier, you can see that the software to other object linkage is far behind the other types of linkage, such as dataset to dataset. And being able to understand that linkage between software, data, models, publications, and all the other parts of the research ecosystem is really important for 3 different reasons. The first one is, for the software itself, it helps improve reuse and sustainability, because the more people who understand and can filter for the software that might be useful for them, the more we can persuade people to reuse and contribute to software rather than creating new software. It becomes much easier to properly apportion credit, which again helps with sustainability and maintainability, because the authors and contributors to software are more able to show the impact that software has. And it does help us to better understand the impact of software. We know it's out there. We know that we know that research relies on software, but I think we don't really understand how much software is the foundation of the research that we do today. So I'm now going to hand back to Rachel so that we can talk a little bit more about the European angle.
That's great. Neil, thank you very much. I think the next person I'm handing over to is Paolo. You should be able to unmute and to share your slides, but let me know if there are any issues with that.
Hello, can you hear me?
Hey, yep.
Hi. So I need to share my slide, okay? Yes.
Yep.
That would be quick, I hope. Slideshow. Share my screen. In the meantime, Neil, can you read the question that I had for you? Well, it's not a question really, it's more like a comment. Yeah, it's in the chat. I can't find it. Where's Chrome? Here it is. Okay, can you see it?
Yep, you're all set.
Okay. So I only have 3 slides. It's just a comment, and just to echo what you said and what Neil has very nicely mentioned. So research software is clearly a first-class citizen in the scientific area. There are so many activities around it, from the consolidation of an idea of persistent identifiers. We have the explicit, the inherent identifiers. We have software repositories that are today ready to accept, let's say, the published version of software, providing a DOI for it, for those who like DOIs. We have a preservation infrastructure, especially in Europe. We have this idea of building a universal software archive, and the softwareheritage.org, that is doing amazing things on this matter. And then, of course, as we have touched upon in this webinar, we have the idea of providing semantic links between software and other products. This is to say that the whole open science publishing infrastructure is actually evolving in this direction. So we have the same phenomena for data, for software, and we have links with publications. We are linking these objects and trying to record and track their evolution in the scholarly communication research assessment infrastructure. So we have initiatives like COARA that are trying to take this into account. So what it means in terms of impact and so on. And for this reason, in OpenAIRE, in building the OpenAIRE graph, we have included software as a first-class citizen since many years today. Only recently, we have made sure that when we expose the content of the graph according to Scholix, we also have this software resource typing attached. That makes a big difference. Actually, it's supposed to make a big difference in terms of the distinction between research data and research software, and of course, research publications, and how these are interlinked. As you can see here, this is the total number of records that we have, more than 330,000, which is a good number. Keep in mind that for research data, research publications, we're going up to the millions. So like 50 to 60 million research data sets and close to 200 million publications. So software is a newborn, let's say, from this point of view. And as you can see, researchers are storing it everywhere. So Zenodo, GitHub, Figshare, and in many sources at the same time. For example, we are not collecting directly from software heritage because it's much more than research software in there, but we are trying to find a persistent identifier in software heritage whenever we find a piece of software in any software repository that is being cited by a paper. So it's a result of full text mining and hooking to software heritage. As you can see, many of the publications linked to research data set do not expose directly this link, but we rather infer it. If you look at the right column, 89,000 of the links that we are including in the graph are being inferred from research paper full text to a software repository out there. One of the, we search into the known ones, Bitbuckets and GitHub, of course, and then into software heritage. So it's not still, let's say, a normal practice, as Neil was saying, to cite the software. We rather go and cite the paper. That's the other thing. And this complicates things. And then, as I mentioned, the OpenAIRE graph has an API that is called Scholix Explorer that gives access to the resolution mechanisms that allow from a DOI, from any persistent identifier out there. So archive identifier, PMC identifiers, DOIs, PDBs, any PID considered out there, including handles, to be resolved into the identifiers that are linked to it with a semantic link, together with the semantics of the link. Okay, now when we observe this and the numbers, especially the numbers that Neil has provided, this is to go back to the comment that I made. I think the main problem here is to agree on resource typing. Okay, what is exactly research software? What we should tag as research software? because in the majority of the cases, we are trusting the metadata as it comes from the repositories, as it comes from the publishers, and so on. And there is no real data curation behind it, okay? So the majority of scientists are publishing their own stuff into free repositories, from the institutional to Zenodo, Figshare, without any particular care of following the practice in what is research software, on the specific definition on how to link to it. So if we had to give priorities, I think the important one is to agree on a clear interpretation of software, which is code, okay? And then make sure this interpretation is widely used by scientists worldwide and by the platforms. And this is, I think, the main problem today. So when you look into Zenodo and you search for software, what you find there is not necessarily software. In fact, it can be any sort of stuff. You can find XML documentations, you can find pieces of workflows, you can find data uploaded in Github and then uploaded in Zenodo, which is tagged as software. You can find so many exceptions, including tools, okay, which are not necessarily software. So it's a big mess out there in terms of how we type things, how we name things. So metadata typing or metadatizing is really important, but somehow is second in the line, because you can give us very good metadata, but if what you're tagging is not software as we are supposed to intend it, then we fail in the mission. Our numbers are screwed, our interpretation is screwed, and it's really hard to even analyze the current scenario. I think it's a good start. So what we're doing here is very important. Also having services like School Explorer or the Open Graph allow us to study the practices, study the environment, and understand where and how we can steer it in the proper direction together, I mean, as a community. Okay, so I'm done. This was my last slide. So questions and discussion. Rachel, the hot potato goes back to you.
Thank you very much, Paolo. And I appreciate the discussion in the chat. And I think, I guess, kind of probably a couple of comments. So I said, feel free to drop questions into the chat. Paolo, if you want to stop screen sharing, then I can have a look for people putting their hands up as well. But I do know, as you said, that that this is something that we've come across with data citation as well, in terms of what people, what gets tagged as data in the metadata versus what's actually at the end of that persistent identifier, or sitting in a repository. So, and Paolo, yeah, you've made the case that that's not limited at all to research software. So I am interested in, as I said, because when we were thinking about these, you know, making these recommendations, then we definitely want to accompany those with clear guidelines to sort of to help support this being used in a sensible way. And I think there are other things that we can do as a community, and some of which are already being done to be able to enforce, if not a uniformity, more consistency than we're currently seeing. Neil?
Yeah, I was just going to kind of come on to that point that Paolo made. I think the thing that really resonated was the point that it's basically around curation, and for a lot of research software, the difference is that it's almost like you're self-publishing. So you're putting something up on Amazon or Lulu or one of the other self-publishing platforms, and you yourself are responsible for the metadata, and no one's really curating it. They're trusting your entry, whereas the bulk of scientific articles, research publications go through a curation process for the metadata, and that's a challenge. However, I guess if we can make it easier for people to understand how to properly assign things, that should make the quality of content better. The other thing might be around, is there a process for helping people suggest changes or where things have been mistagged, because yeah, there's this isn't just a research software problem. This is basically a self-publishing problem.
Neil, yeah, fully agree. I'm actually trying to finalize a paper that's exactly on that topic. And it touches upon all these issues on the different typologies of objects that are being today shared out there. I mean, it is the problem of open science, which comes with a lot of very good added value, but misses completely, as I call it, the gatekeeping part. Okay, so there's no way to have your objects go through the what we are used to with the papers, a sort of both peer reviews, metadata curation, and a clear and common understanding of the scholarly record. So we publish based on common sense, following our practices, often in a hurry, and the result is a big mess. There is also another interesting distinction, which applies to software very much, which is the distinction between a research product and a product for research. Okay, so especially with research software, this is particularly evident. So some software is not the result of a research process, but is very useful to perform science. Okay, and in some cases, instead, you have software that is a result of science, which is then supposedly be part of the research assessment, which can in turn, of course, become a product for research because it may be well used to do other research. But in this case, the citation is different. One is for reproducibility, the other one is for research assessment. Okay, the same principle applies, not surprisingly, to research data and to many other things out there. So there is plenty now of researchers who are publishing stuff that is useful to others, and this stuff is not a research product. For example, scanning an old book, right, which now can be accessed by somebody else, but you, that are the author of the scan page, are not providing, an added value or innovation into the world. Still, you're an author of that, right? Because you scan the page, and these can be accounted for your CV, and it's the same for research software.
Yep. Neil, I'll let you jump in again.
I was going to mention two things that I just popped in the chat there that I think is still active kind of areas of discussion. So one, responding to Paolo, is should citation be used to support reproducibility? And I think that's quite a dangerous thing from my perspective, because whilst it sort of worked okay for ensuring reproducibility when we were referencing papers, it didn't really. It's really more a way of linking things together rather than supporting reproducibility, and it fails even more so if we're trying to do it, use it to support automated computational reproducibility. I think kind of the primary purpose here is credit and attribution, and understanding related works. But the big one for me, so we recently had the last call for the software citation implementation working group, and one of the big things that was raised as being what needs to be understood next is that there's been a big rise in complex objects which contain code, documentation, papers, articles, data sets, models, particularly with the rise in a lot of content and research that has AI plus whatever disciplinary problem is being addressed. And I don't know that we've worked out how to properly cite these and how to properly reference them and how to properly understand what they are, because I think the kind of thing that strikes me is that we can have things which are both software and data set and publication now. I think for a long time we've considered these to be distinct and separate, but we're now seeing things which are all three, and that's going to really disrupt our ability to analyze and link things.
Yeah,
true. But I mean, Neil, on the other hand, in computer science, we are used to have many types for the same objects. But no, just to add on what you said, I think it's not really reproducibility in the way you mean it. So the actionable reproducibility, which maybe to some extent is applicable, but is more about tracking when you are accessing, but via one product, the context of a wider research that includes other products, okay? And in that sense, it's really useful. If I find a software, for example, to go back to the original paper that describes it, as well as to the paper that has cited it in this specific context together with the data. This is, of course, lightweight reproducibility, right? So I'm finding everything that these guys have done in a certain context, and therefore I'm able to better understand what they've done. It's not just about referencing here. It's not just about attribution, because, for example, the supplemented by, I think, is a critical kind of link, because it takes you back to the original paper that has contributed to the generation of an object, which is very different from those that are citing it. Okay, that's where the attribution comes up. The supplemented by is not really about attribution, but it's more about saying, hey, here you can find everything that is behind the scenes of this object, of this product. I know the mathematicians are doing this very well in their software repository, where they keep links between, and they are actually capable to go back to the original paper, which I think is fantastic, right? So whenever you use a piece of software, you have the list of citations to it, plus they go back to the original, the source, right? And that's something that is missing as a practice. And this group, I think, could suggest as one of the practices to be imposed, which is lightweight, if you want, reproducibility in a way. But I agree with you, we shouldn't think of the automation here.
Yeah, and I feel like, as you said, we had I think sort of looking across, and I think this is interesting across the different groups, and certainly at one point we had quite a deep conversation as you said, into how far this could actually support reproducibility. And Neil, exactly to your point, things get very complicated very quickly, and I sort of feel like I work in, you know, product management, and it's, you know, to say something's out of scope always seems like kind of a very easy answer. But as you said, I know that there are groups that are talking about this, working on this, thinking about the kind of nuance on it. So Paolo, I guess I'd kind of echo your sort of like, let's start with helping people find where the things are that that underpin and, you know, that are part of the research. And I think that helps us get a bit further. I think the encouraging thing, as you said, like, nobody's coming out and saying, we've totally cracked it. These are all the things that you need to do. But we can all sort of follow these, keep following these directions of travel to be able to build sort of better community support for software. So I think that's, as you said, it's sort of reflective, and I worry, as you said, that I know that other folks that I work with are involved in the, as you said, the sort of the more complex citation, and really kind of getting into the guts of reproducibility. I would say we've got about 2 minutes left. So let's wrap up, because I imagine that a lot of you have more calls to go to after this one. I'd really thank you for coming along today, for your questions, for your input, and obviously to the speakers as well. I hope that's really helped with the context and showing the work that's already been done in this area. We'll share out the recordings and aim to continue the work on this in parallel. And again, hopefully we'll see some of you at the next plenary later this year. But yeah, thank you again. Useful feedback, good comments. let's keep going on this. All right. Thanks again. Goodbye.
Thanks, Rachel. Thanks all. Thanks, Neil.
Thanks.
Bye.